We are going to go over the probability rules and principles in this lecture. You should have already gone over the fundamentals or the beginnings of probability as well as the objective and subjective probability. Just a reminder, probability is a scale of 0 to 1 inclusive of the likelihood of an event occurring. And we're going to look at some more information here on objective probability. So by the conclusion of this lesson, you'll be able to calculate probabilities using the rules of addition, and you're also going to be able to calculate probabilities using the rules of multiplication. Okay, so the rules of addition refer to the probability that any two or more events can occur. Okay, so we have event A, event B, event C down below. The special rule of addition, notice here, special rule of addition, is specifically used when the events are mutually exclusive. If and only if the events are mutually exclusive can you use this, where the probability of A or B occurring, so either A or B occurring, equals the sum of the probability of A and the probability of B occurring. Okay, so let's take a look at an example. Here's an example where an online t-shirt company uses a software program to provide estimated shipment arrival dates to their customers based on current production queues. Based on a sample of 4,000 shirts, the company tracked the probability of occurrence of the shipment arriving early, on time, or late. Okay, so the shipments that arrived early is event A, and the number of packages that arrived early was 500. The number of packages that arrived early is event B, and that's 3,200. The packages that arrived late was 300, and so that gives you the distribution. Okay, 500, 3,200, and 300. And then the probability of occurrence. In order to determine probability, you divide the occurrences by the we're essentially creating a frequency distribution here, and this frequency distribution gives you the probability of occurrence that you are going to generalize to the future population. Okay, so the probability of occurrence right here is 500 divided by 4,000 gives you 0.125, or 12.5%, is the probability of occurrence. 3,200 divided by 4,000 gives you 0.80, is the probability of occurrence, and 300 divided by 4,000 is 0.075. Okay, so you want to know what is the probability of A or C occurring. So you add the probability of A and you add the probability of C, or add the probability of A to C, and that gives you 0.20 is the probability of A or C occurring. Okay. So the next rule is called the complement rule. Okay, and it's basically saying that the complement rule is to determine the probability of an event happening by subtracting the probability of an event not happening. Okay? So the probability of A not happening is 0.875. 0.875. And the reason why this works is the probability of all occurrences happening, if it's mutually exclusive, will add up to 1. The probability of mutually exclusive events occurring will add up to 1. And so probability of A equals 1 minus the probability of A not occurring. Okay, so the probability of 0.87, or the probability of B and C, you subtract that from 1, and that gives you the probability of A. Okay. So, or for instance, the probability of A or C equals the probability of B not occurring, which is 1 minus the probability of B, which is probability of B is 0.80, So 1 minus the 0.80 is 0.20. Okay, so just ignore that. It's supposed to say 0.80. Okay, so the general rule of addition is used when the events are not mutually exclusive. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so once again, when the events are not mutually exclusive, you have the probability of A plus the probability of B minus the probability of A and B. Okay, and joint probability is a probability that measures the likelihood of two or more events occurring concurrently, which is the center part right here. This is joint probability, the probability of both of them occurring, even though they're separate events, of both of them occurring. So here is an example of the general rule of addition. A sample of 200 tourists in Waco showed that 120 tourists went to the Magnolia Silos, and 100 visited Baylor, and 60 visited both of them. Okay, so you've got a total of 200 tourists. Of those 200 tourists, you have right here, let's see if we can, you've got 120 visiting the silos, you've got 100 visiting Baylor, and then you've got 60 that are visiting both the silos and Baylor. Okay, so in order to do the rule of addition, come down here, and you've got 60 or 0.60 0.60 plus 0.50 minus 0.30. So the probability of the silos plus the probability of Baylor minus the probability of both gives you the probability of okay, so here's an example of the general rule of addition. Right here, we've got a sample of 200 tourists in Waco, and it shows. Okay, so here's. Okay, so here is a slide on the general rule of addition. This is an example. So here we've got a sample of 200 tourists in Waco. That it shows 120 went to the Magnolia Silos when they visited Waco, and 100 visited Baylor, and 60 visited both. So you can see right here you've got 100% of the Waco visitors, 60% of the silo, and 50% visited Baylor. And there's this sweet area right here, which is a joint probability area where 60 out of the 200 visited both Baylor and the silos. Okay, so this area right here, 0.30 probability, is the probability of the individuals that visited both. 0.6 is the probability of visiting just the the probability of visiting the silos, and 0.5 is the probability of visiting Baylor. Okay, so in order to do the general rule of addition, right down here we have the probability. Whoops, let me go back. We've got the probability of individuals visiting the silo plus the probability of them visiting Baylor, and you subtract the probability of them visiting both the silos and Baylor to determine the probability right here of the individuals visiting either the silos or Baylor, but the silos or Baylor. So there's essentially 20% of individuals, or 0.2 is the probability. Is the probability of an individual not visiting the silos or Baylor. Okay. So the rules of multiplication are applied when two or more events occur simultaneously. The special rule of multiplication refers to when these events are independent. Okay, once again, independent means that the occurrence of these events have no effect on the probability of the event of the other event occurring. Okay, so once again, this is a special rule. When you see special rule of multiplication or special rule of addition, this means that the events are mutually exclusive or independent. Okay, so a survey by the American Automobile Association revealed 60% of its members made airline reservations in the past 2 years. 2 members are selected at random. What is the probability that both made airline reservations last year? Okay, notice these are completely independent. One individual, there's 2 members that are selected at random. The probability that one will have made an airline reservation is 0.6, and that 0.6 has no effect on the other individual. Okay, so 0.6 times 0.6, which is the probability of the first one and the probability of the second individual at random, both making airline reservations within the past year, the probability is 0.36. Okay. So the general rule of multiplication refers to events that are not independent. Okay, so the general rule means that they're not independent or they're not mutually exclusive. And then a conditional probability is the probability of a particular event occurring given that another event has occurred. Okay, so the probability of A and B occurring equals the probability of A occurring and the probability of B given A, or the probability of B occurring given that A just occurred. But it's red when you see P right here. When you see P and then BA, this is red. The probability of B given A. Okay, so the general rule of multiplication, let's look at an example. A company is conducting an interest group study to see if children prefer vehicles or animals when they're playing. Okay, if 2 children are put in a room with 6 vehicles and 6 animals, if the first child grabs the bear, this bear right here, what is the probability that the second child will also grab another stuffed animal? Okay, so you've got, first of all, what is the probability that this child will grab the bear? Okay, we're going to count. There's a total of 12. There's a total of 12 items, and of those 12 items, 6 of those items are stuffed animals. And then let's see here, the other 6 are vehicles. So the probability of an individual grabbing the bear to begin with is 6 out of 12. Okay, so 6 out of 12. Or if you were to divide that out, the probability is 0.5. Okay, and then you have the probability after that. There's only 11 items left. You see 11 items, and of those 11 items, only 5 of them are stuffed animals. So now there's 5 out of 11. So you multiply 6 divided by 12, and you multiply that by 5 divided by 11, and that gives you a probability of 2 independent events occurring of 0.227. Okay, so the first one, you've got a probability. There's 6 stuffed animals, and there's a total of 12 toys. And then the next one, there's 5 stuffed animals, and there's a total of 11 toys left after the first child grabs the first stuffed animal. So that is the end of the lecture on the rules of addition and multiplication with probability. Hopefully you are able to put this into practice with your exercise. If you need to, feel free to watch this lecture as many times as you want, or post some questions to the discussion board, and I'd be glad to answer any questions that you might have.